Okay, and now we get to lesson number 5 of the unit. This is the last new lesson of the unit, and we want to be able to describe the effects of proportional dimension changes. In other words, what happens if we double each dimension, or if we multiply each dimension by 3, or perhaps we multiply each dimension by 1/2. Now, quite some time ago, when we were doing the proportionality, we were doing the transformations where we said what would happen if we doubled every dimension or if we tripled every dimension, and we discovered that the resulting figures were similar to the original figure. Right? They weren't congruent because they were no longer the same size, but they were similar because they were still the same shape. So now the question begs, what happens if we multiply by number k? Specifically, the perimeter and the area. Well, if the original perimeter is p, and we multiply by a number k, the new perimeter is k times p. So if we double each dimension, we double the perimeter. Now, area works quite differently, however. If the original area is a, and we multiply every dimension by k, the new area is k squared times a. In other words, if we doubled each dimension, instead of doubling the area, we'd multiply the area by 4. So we're going to take a look at a circle. And what if the radius was 5? What if the radius was 10? What if the radius was 15? And first of all, we're just going to do it the way we have been. And of course, perimeter for a circle, we always call it the circumference, but it's really the same thing. All right, so when we talk about the circumference of a circle, it's basically the same as the perimeter. Well, if the radius is 5, we know the circumference is 2 times pi times the radius. And so the circumference would have to be 10 pi. Area of a circle, pi times the radius squared. Well, the radius was 5. I better plug in 5. 5 times 5, of course, is 25. So the area would be 25 pi. Now, I want to do the same thing when the radius is 10. Let's find the circumference. 2 times pi times the radius. So, of course, that's 2 times pi times 10. And, of course, 2 times 10 is 20, so the circumference is 20 pi. Area, of course, is pi r squared. The radius is 10, so I need pi times 10 squared. 10 times 10 is 100. So it's 100 pi. Okay, radius of 15. Circumference, of course, is 2 times pi times the radius. So I need to do 2 times pi times 15. 2 times 15 is 30, so the circumference is 30 pi. Now, for 15 squared, this might be the first time where you're like, whoa, I got to grab a calculator, right? 10 times 10 is 100. Probably did that in your head. 2 times 15 is 30. Probably did that in your head. But 15 times 15, let's face it, most of us don't go around memorizing 15 times 15. So I'd grab a calculator and come up with 225. So the area would be 225 pi. So that's how we had been finding circumference and area. Now, let's look at if the explanation on the previous slide is true. So we've got our original radius of 5. But to get a radius of 10, we multiplied by 2. To get a radius of 15, we multiplied by 3. So we've got our original dimension of 5, and then we use the scale factor of 2, k equals 2, because 5 times 2 is 10, and then we use a scale factor of 3, because 5 times 3 is 15. So I want to compare the circumference and the area with the original dimension, multiplied by a scale factor of 2, and then the original dimension multiplied by a scale factor of 3. Well, if the original circumference was 10 pi, and the original area was 25 pi, what should happen when k is 2? Well, 2 times 10 pi is 20 pi. Sure enough, that's what happened. 2 squared times 25 pi. Well, 2 times 2 is 4. 4 times 25 is 100. We'd get 100 pi. Sure enough, that's what happened. If we double the radius, we double the circumference. If we double the radius, we actually multiply the area by 4, because that's 2 squared. What if k is 3? Again, I got to take the original circumference of 10 pi, multiply it by 3, I get 30 pi. Sure enough, that's what happened. Take the original area of 25 pi, but multiply it by 3 squared. 3 squared is 9. 9 times 25 is 225. Sure enough, the area was 225 pi. Now, I just did this with a circle because we'd only have to worry about the one dimension, the radius. But this works the same with a square or a rectangle or a hexagon or a pentagon, triangle. Doesn't matter what the shape is. If you multiply every dimension by a scale factor of k, you multiply the circumference or the perimeter by k, and you multiply the area by k squared. So we've got a worksheet, and then we've got some IXL we can work on.